Okay, let's look at another example of applying L'Hopital's rule. So let's remember that L'Hopital's rule says that if you're evaluating a limit as x approaches some real number a, or positive infinity or negative infinity, and we get a indeterminate form. When taking the limit of a quotient, you get 0 over 0 or some infinity over another infinity. We can apply L'Hopital's rule that says that that limit must be the same value as the limit of the derivatives of the numerator and denominator. One thing to be careful of is you'll note that we're not doing any kind of quotient rule because I'm not taking the derivative of f over g. I'm taking the derivative of f, and then I'm taking the derivative of g. So let's grab another example that we could use. And I think this one would be a nice one to do. So we'll use it. Okay, so let's evaluate this limit. I'm going to plug in 0 for x on the top, and I get the sign of 0 is 0. On the bottom, I get 0 as well. Well, that's not allowed. 0 over 0 is indeterminate, so we have a limit that we cannot evaluate as it is. Well, let's apply L'Hopital's rule. So in order to get credit for using L'Hopital's rule on an exam like the AP exam, you have to set up the theorem. And that theorem says that the numerator's limit, so let's document that. Let's take the limit of the numerator, and we have to spread it out like this. You can't just jump to a quotient of limits or things like that. You have to do it one at a time. 3 sine 2x. Okay, I'm going to plug in 0 here, and I get 0, so I will document that that limit is 0. All right, then I'm going to show that the limit as x approaches 0 of the bottom well, that is also 0. So because the limit of the numerator and the denominator is one of our indeterminate forms, we can use L'Hopital's rule. All right, so by L'Hopital's rule here, we can state that the limit as x goes to 0 of 3 sine 2x over the sine of x well, that must equal, get a little bit more room here. All right. Well, that must equal the limit of the derivative of the numerator over the derivative of the denominator. Well, let's see, the derivative of 3 sine 2x. Okay, the derivative here would be 3. The derivative of sine of u is cosine u prime. So that's cosine 2x. Now I need to multiply that by the derivative of the inside, which is the u prime, so times 2. All right, so we've done the top. Now the bottom, the derivative of sine of x, that's simply cosine of x. Okay, now let's see if we can evaluate this. If I plug in 0 on top, I get 3 times the cosine of 0 times 2. Well, the cosine of 0 is 1, so this is really just 3 times 2, which is 6. When I plug in 0 to the bottom, the cosine of 0 is 1. So we know that this limit is 6.